So we can see in this picture we have medium-term scheduling here. Schedule some here. Schedule the CPU. Schedule the process which are running on CPU to the disk. You must know, to the disk, and we say this is partially executed swapped out processes. When the main memory has free space, the processes will be swapped in to the ready queue. So this is medium-term scheduling. The context switch. So before this context switch, I want to emphasize we learn 3 levels scheduler. Which one is long-term scheduler, and the medium-term scheduler, and the short-term scheduler, also called CPU scheduler. Okay, you must remember. In the third section, context switch. As mentioned earlier, interrupts cause the operating system to change the CPU from its current task and to run a kernel routine. Such operations happen frequently on general-purpose systems. When an interrupt occurs, the system needs to save the current context of the process running on the CPU so that it can restore that context when its processing is done, essentially suspending the process and then resuming it. What is the context? You must remember, the context of process is represented in the PCB of the process. Okay, it includes the value of the CPU registers, the process state, and the memory management information. Generally, we perform a state save of the current state of the CPU, be it in kernel or user mode, and then a state restore to resume operations. Switching the CPU to another process requires performing a state save of the current process and a state restore of different process. This task is known as a context switch. When a context switch occurs, the kernel saves the context of the old process in its PCB and loads the saved context of the new process scheduled to run. Context switch time is pure overhead from the user's view, of course, because the system does no useful work while switching. Switching speed varies from machine to machine depending on the memory speed, the number of registers that must be copied, and the existence of special instructions. A typical speed is few milliseconds. Context switch time are highly dependent on hardware support. For instance, such as the Sun UltraSPARC provide multiple sets of registers. A context switch here simply requires changing the pointer to the current register site. Of course, if there are more active processes than there are register sites, the system resorts to copying register data to and from memory as before. Also, the more complex the operating system, the greater the amount of work that must be done during a context switch.